So we're going to play around with testing, prevalence, false positives, false negatives. And so if you're looking at this in the future, there's a link to this spreadsheet. And the two categorical variables I'm looking at here are, do they have the disease or not, right? That's a yes or no. So disease, either yes or no. And then the other one is that they had a test. They were tested for the disease. Test. And the test is either going to come out positive or negative. And any test we do could come out wrong. It says it's positive, but there was a mistake for some reason. And those mistakes can happen just due to the nature of the test or something that went wrong during the test or in the processing. There's just so many things that can happen. So some terminology related to this. So there's an idea called prevalence diseases. And the prevalence is just the percent of cases in the population or in the group. Right? And as far as probability goes, that's just the probability of having the disease. So I would write P for probability, and it would be the probability of having the disease. And in this case right here, I can see in the totals here that the total number of people that have this disease in this group of 1,000 are 300. So the probability here should be equal to that 300 right there, divided by the total number of cases. So this disease has a prevalence of 0.3, and we usually state that as a percentage. So I can click back on that and say, oops, say, hey, give me a percent, please. So there's my 30% prevalence rate. 30% of the population has this disease. That's prevalence. There's a few other ideas I want to mention and what their probabilities are and what they mean. So I mentioned the idea of having a false positive test. So what is a false positive test? So that the test came back positive, but it was wrong, right? That means it really didn't have the disease. So this would be the probability positive test knowing disease, right? It's a mistake. Now, often we really don't know this. Right? It's just, this has to be researched on how to figure out. It's a hard thing to figure out. The notation I would write for that is probability that you had a positive test. I'm just going to use a plus for positive. If, which means knowing, you have, let's see, you don't have the disease. So no. A little bit too big for me there. So let's find that probability in the table right there. So this knowledge here changes everything. So that's all I care about in terms of the false positive, that I know they have the disease. So out of the people that have the disease, okay, they had a positive test. So then to calculate the false positive here, that would be equal the number of, let's see, no, I did something wrong. Oh, don't have the disease, I'm in the wrong column, right? False positive. So of the people who tested positive that don't have the disease, out of all of the people that don't have the disease, because that's my new knowledge. The knowledge always becomes the denominator. So here I get a 10% chance of having a false positive, false negative. So that's the probability you get a negative test knowing you actually have the disease, right? It said you don't have it, but you really do. negative test, but you know you really don't have it. Sorry, you do. So again, probability notation, probability, test came back negative, but it was wrong, so that means you really have the disease. So there we go. All right, so false negative. Test came out negative, they don't have the disease. Test came out negative, sorry, but it was wrong, right there. Negative test, here's all of them. These are wrong, those are right. So the 630, those are true negatives. That's a good thing to see. This is false negative. 15 is my numerator. The knowledge, though, that I really don't have it means I really do have it, sorry, is then everybody that has the disease. So it'd be the 15 out of the 300 here. 15 out of this 300. So again, 5%. I just want to highlight these in my notes, talk about them a little bit more, and then we're almost out of time. So let's look at the false positives again. So false positive. The test came back positive, but it was wrong. So if we're thinking about the positive tests here, right, so we're in this row here, test came out positive for these 285 people and those 70. Now, if the test came out positive saying you have the disease, well, this 285, those would be the true positives. These 70 right here would be the false positives. So those are the false positives, that group of 70. Now, the other thing about a false positive is it's with the knowledge that you actually don't have it. So that changes the denominator. Instead of out of 1,000, I'm looking at the 70 out of the 700. And that's where that 10% comes from right there. So that's the idea of a false positive. The test said you have the disease, but you really don't. So I'm looking at the percent of people who tested positive and had the disease out of all of people, sorry, don't have the disease, out of all the people who don't have the disease. Let's look at false negative again. False negatives. So someone tested negative, right? So I need that. So negative tests are over here. So 15 people tested negative here, and these 63 also tested negative. Now, negative should mean you don't have the disease. So the 630, those are the true negatives. The 15 here, those were mistakes in the negative test. They said they didn't have it, but they really have the disease. And that's the knowledge that we now know that they have the disease. So that's my new denominator right there. And that's where that 5% comes from, the 15 out of the 300. So again, thinking about what a false positive is. The test came back positive, but we really know you don't have it. False negative. Test came back negative, but we really know that you do have the disease. Sorry, we were wrong. And with any test, there are going to be false positives, there's going to be false negatives, there's going to be true positives and true negatives. And all of those are conditional probabilities. So again, important part I'm trying to get at here is these conditional probabilities. I'm going to write down since we're on the false negative page, let's do that one again. So the probability of getting a false negative could be also considered the probability that you tested negative. Right, so negative says you don't have it, but it's a mistake, right? It's false. So that means you must actually have the disease. So there's the mistake, the error. And the rule for calculating those is the disease here, this new knowledge, that becomes your new denominator. And so if I then, I'm going to put a C here for count. If I count the people that are negative and have the disease, and I divide that by the count of people that have the disease, that gives me the proper rate. And so again, this one here, negative and has the disease, right? Look at the negative column. Where does it overlap with the disease column? That's that 15. And the disease is my new denominator. So that 300 there. And then usually we rewrite that as a percentage, and these happen to come out nice. I picked nice numbers to start with, but some of them are going to be messy. We'll do some messy numbers next class. Okay, so what have we done today? Just going to get back to our home page, and I will publish the homework in about an hour for you to take a look at. We're trying to get the idea of what a basic probability is. And it's a fraction of some kind that can be written as a percent or a decimal. I mentioned that some things are equally likely, like flipping a coin or drawing a card out of a deck, maybe, or rolling a dice. But most things in life aren't that easy. They're not equally likely, like shooting a basket, or will I get into an accident or not today? Will my daughter play piano today or not? Will my mother go get her second vaccine or not? So there's all these other probabilities that aren't equally likely out there. So that's something we have to be careful about, that assumption that we try to make things too easy sometimes. We looked at language, like the idea of and or, of the idea of a complement of a set in this conditional if idea. The complement, additive. I haven't talked about multiplicative yet. We'll get to that next time, but we did start looking at the ideas of conditional probabilities from a two-way table. And I'll talk more about disjoint events later. That's not as important, but the big ideas here are related to this conditional probability. And that's what the next chapter is pretty much just about. And so we'll draw some tree diagrams next time to play with these conditional probabilities that I think are important. And there's a rule you can apply called Bayes' rule, which is a formula. I'm going to present it, but I don't really like it. I find that we can just look at a table like we just did today, and the table can do the problem way easier. So we'll compare using Bayes' rule to using a table, two-way table to compute probabilities. So I've covered kind of 80% of what we need to do this week. And then next class, we'll just kind of play around with more examples, look at some data related to COVID and heart disease, and a few other things. And then we can talk a little bit more about the exams. I'm sure people have some questions and concerns about that. So that's it for now. Thanks for playing. If you have any questions, feel free to hang out. Otherwise, have a great day, get some sunshine.